So I am going to plan to talk about cognitive functions in a single class period here. I ended up skipping all of the internal regulation that the brain does. I think the highest ratings were for reproductive behaviors, and even those, even if I included sexual orientation and some of the other questions that were there or statements that were in the interests, cognitive functions won out, I think, in both classes. So I'm going to do a sliver of the cognitive functions today. I'm going to start this by repeating this lateralization of the brain, and I'm not going to go into the specifics and the details because we've done this, right? We did this when we talked about consciousness because I wanted to talk about split brain patients, and so we had to talk about a great deal of this lateralization, which basically just means that the brain is lateralized, that the different sides of the brain are really performing different functions from each other. When we talk about these kind of bilateral structures, for the most part, the subcortical structures are doing pretty much the same thing bilaterally, but when we get up to the cerebral cortex, there is this lateralization where each of the hemispheres is performing a bit of its own bunch of functions. We have the communication through the corpus callosum, which was what was severed in the people who were split brain patients. We also have some communication through all of these different commissures. Just some general basics from what we've learned from cutting the corpus callosum. The right hemisphere is very important for emotional expressions. And here, an old edition of Calit, but I like the picture and what he's saying here. So this is half of a smiling face, and it is just spliced onto a regular placid face, which looks happier to you. A, with the smile that is on your left, so that really, if you're looking right at the face, that's going to your right hemisphere. Or B, the one with the smile on your right, which if you're looking right at him, so kind of where his nose is the fixation point, then the right is going to your left hemisphere. And your answer might suggest which part of your brain is doing this, is more responsible for this emotional processing. A lot of people say the A, the one where he's smiling on the left, because that's going to the right hemisphere. I actually have a hard time with this picture, and it's hard for me to tell. Anyway, left hemisphere is dominant for processing language in most people. And so this is actually what we saw with the split brain patients. So if they're seeing the words hat band, okay, and that's actually in their central vision, that if something's over to their right, then they're going to kind of pick out verbal cues, but if something's over to their left, they might pick up with their left. So what's being processed by their right hemisphere, they can pick that up, but they can't get to the verbal cues of describing this is the hat band, but they can pick up the hat. Okay, what this picture is showing is that the planum temporale, which is being pointed to on in both hemispheres of the brain, is typically larger in the left hemisphere than in the right hemisphere. And that is true for about 65% of the people. And if we look at kind of right-handedness, what this suggests is that this has something to do with maybe that motor, but it's not so much motor, right? Because that would be in the frontal lobes. They also found this, so research has found that this was true in 12 of 14 infants who died before the age of 3 months, and that this is true in preterm babies, and that this is true when they look at the fMRI of young infants. So typically we just have a larger planum temporale, in the left hemisphere than in the right, which suggests this kind of right-handedness and that something is different about the left hemisphere, potentially because of that. That's always been my assumption, is because of right-handedness. We see smaller differences, but they are still there in chimpanzees, bonobos, and gorillas. So this is apparently something that we've really even can see in our ape-like ancestors. I have had students ask me some questions about this more recently, as I've had this psychology of music class where well more than 10% of the people are left-handed, and they had some questions, and I said, well, I don't know actually as much about left-handed people specifically. A lot of things appear to be kind of switched, but I think that's all of this. So even talking about the lateralization of the hemispheres earlier, it's all so overstated, as these kind of generalizations are, that I don't think it's that easy and clear a picture. But these are just some percentages of 65% of people have a larger planum temporale in the left hemisphere. And this is typical of infants and other animals. So that brings us, I think, hopefully logically, to this idea of hemispheres, handedness, and language dominance. So for more than 95% of right-handed people, the left hemisphere is strongly dominant for speech, for language. And so again, we see this at the typical percentages, proportions, estimates that I've seen is that about 10% of people are left-handed, about 90% of people are right-handed, and here we're looking at 95% of right-handed people. The left hemisphere is strongly dominant for speech. Left-handers are just more variable. Okay, if you know anything about my background, you will know that my interest in graduate school was language comprehension, and especially the ambiguity of language and how we understand each other, given how often language is ambiguous. And I ended up looking at eye movement behavior, but all of our language and the speech and everything is so ambiguous that it fascinates me how complicated it is. And many of my friends, what I thought maybe I should have gone into was language production, because when I went to graduate school, many of my friends were in language production, and it is this whole, how do I get the thoughts that are kind of in my head that are not some easy linear thought to discuss? How do I get that into this linear stream that we call language? I'm going to do a little bit of this evolution and physiology of language, but really talking about some of these primate, non-human precursors of language to start with. So many different researchers have examined, they started examining chimpanzees because their DNA is something like 98.8% the same as our DNA. These are our closest ancestors. And what they found was that chimpanzees really don't speak the way we can speak. There's a lot to our articulators and the way that our just kind of our throat goes down and where our vocal cords are that allow us this really complex, this ability for these complex kind of phonemes that put together our language. And so what they ended up doing with chimpanzees was to use American Sign Language, ASL, because chimpanzees do gesture a lot. And when they speak, not only do they not have the sort of specific kind of articulation that we can do, but they have this, they're breathing in, I can't even do it. They're breathing in when they talk. And so try that for a little while and see how we breathe out as we're talking, and it's easier. So to understand what chimpanzees understand, they started using these kind of symbols that were gestural. And chimpanzees can learn to communicate. we can ask the question if using symbols truly means this is a language. And you might want to pause here and think about that. I suggest that you do. Again, I'm super fascinated by language, and I'm going to probably argue here that it's more complicated than that. But I'm also, if you know who I am, a little bit about me, that I'm very pro animal, and I don't think that humans are particularly special animals in some ways, that like all animals are special. So I'm not really sure where we kind of get this, oh, we're so special because we have syntax, was what some of my friends used to say in graduate school. And we had just figured out that elephants communicate in these low frequency sounds that nobody ever even knew they were communicating in, because we can't hear them. And with dolphins too, I just thought, how do you know they don't have syntax, and what does that really mean? Anyway, I really have a lot of respect for animals as well. So with chimpanzees, they were using this kind of gestural ASL to communicate, but what they found was that while they were using these symbols to represent other things, as language does, they were not particularly productive. Okay, which I'm going to talk about in a bit, as to how we really have this generativity and this ability to produce pretty much any sentence that we want to produce. And if I want to say, you know, the sky was laughing clearly at the plants, I can say that. And you can have some understanding of what I'm saying, even though that is practically nonsense. But I can say it because we have this productivity and generativity. So people started working with bonobos, and it was a particular group of people, Sioux Savage Rumbaugh, Dwayne Rumbaugh, and some of their colleagues started working with bonobos, and they had a particular bonobo, so they're not as closely related to us in their DNA, but they seem to actually do a little bit better with understanding our spoken language. And they were working this with this female bonobo, Matata, who was learning some things, pressed symbols that lit when touched and so forth. But her children, so Kanzi and Malika, as they were these young bonobos watching their mother, they learned by watching her 150 English words. They were able to respond to novel, so unfamiliar spoken commands. And they were compared to a 2 to a 2.5 month old child, okay, where they could understand more than they could produce. They could follow these kind of unfamiliar spoken directions, and maybe somewhat unlikely, like get the tomato into the microwave, is an example. They used symbols to name and describe things, and not just when they were requesting them, which was pretty typical of a lot of the research with primates, is if they're asking for something, they'll use the symbol for the thing that they want. They could use symbols to describe past events. So what is the example they give? Matata bite, to say that the cut they received was from their hand, on their hand was from their mother a bit earlier. And they could make original creative requests, like asking one person to chase another. So they were pretty productive with their language, all things considered. I'm doing a little bit of jumping around, as I usually talk a little bit about non-primate language as well, but I'm going to go ahead and save some of that because I'm going to ask you to watch some videos after I finish this. So some of the similarities between human and animal communication are the arbitrariness. So I usually give this example of dog is arbitrary as far as what I'm calling my dog. And I can call her Chi-Chi, which is her name, or I can call her Chucho, which is one of the Hispanic equivalents down in one of those countries, maybe Ecuador. Perro, chien, hund, those particular sounds that are symbols for dog are really quite arbitrary. And we see this in animals as well. So there is a particular kind of monkey that can say, you know, it's a snake, it's an eagle, and those are arbitrary kind of connections. It's not always arbitrary, but sometimes we see this in animal communication. We also see the transmission of important information. So actually this is the main overlap between animal communication and what we do as humans, is if there is important information to transmit to others of our species, of who we can transmit this to, this is what communication is for. So whether it's dangers or honey or courtship, there's this ability to tell my fellow bees where the honey is. And for bees, it's not so arbitrary. They do this kind of waggle dance where they communicate about where they are right now in relation to the sun, and then they basically give a map in a very small three-dimensional space, but almost two-dimensional space, to tell the fellow bees where the honey is in comparison to where they are right now. But this is part of what we do as well, right? We transmit important information. Some of the differences between human and animal communication. Well, one, our communication is much more flexible. So monkeys can't get together and decide to change raup from eagle to snake. And in fact, they can't say raup. Used to mean eagle, but now I want to say whoop, and that means eagle. Whereas we can, because not only can I say I'm going to go search for that, but now I can go say I'm going to go Google that, and I can mean the same thing, right? And that shows the kind of flexibility of our language. Monkeys can't do that, okay? They don't have words for every object that they see. They have words for specific objects that are important to the group. For this example, the eagle, snake, those things that are particular dangers, they do distinguish. It's not just raup, there's danger, but raup, there's an eagle. Okay, versus rrp, I don't know their name, I don't know what noises they make, but rrp, there's a snake. There's a particular difference to those dangers, and they can distinguish those. But really, what they have words for are these specific things that are dangerous to others. Typically, they have a lack of generativity or productivity, which is what I was just talking about with I can't remember the sentence that I used, but the clouds are laughing at the plants or whatever, that I can say anything I want to say. I usually make you guys come up with a sentence you've never said before. And sometimes it's really helpful what students say. I think one of them said, the hamburger just ate the girl. Sometimes you can tell that this is something that is brand new, not just in the production of the speech, but something that maybe none of us have really thought much before. Some people just say, I'm not a gamecock, or I'm a Clemson Tiger, or something that they've never said before. But regardless of how you look at it, we have a generativity to our language. We can be productive with it. We also have displacement, which other animals tend to not have much ability for displacement. They can't, so those monkeys, they can't say, oops, sorry, that wasn't an eagle. Past tense, not, no, let's not. Because so this ability to talk about the past and to talk about the future, that's not really there. But you'll notice with those bonobos that they could explain things that happened earlier. So I'm going to again say that this is typical, but it's not always true. But for animals communicating with each other, they don't do this kind of talking about the past or talking about the future as far as we understand their language. So this is a great place to stop. I'm going to stop here, and I think I have right now in front of my face 2 links, but one of my students one year, I haven't taught this topic in maybe 4 or 5 years. One of my students one year brought up this dog, and I'll have to go see if I can't find that video as well, of how much some of these animals are understanding and communicating. And you can go back, and you might want to write down some of what I talked about before of, you know, lack of displacement, lack of productivity, and all of those things, and say, is this really true for Coco the gorilla? Is this really true for Alex the parrot? Is this really true for this dog that I'll have to go look up now? So watch the videos and come back to the second video lecture.